Equations involving logarithms. So in this case, we are going to have to find a value of a variable which we will need to apply logarithm to be able to determine. So for example, in the example 1 here, we have 3 to the power x, and this expression is equal to 8. So if you are to solve, I'll say find logarithm to both sides. So 3 to the power x is equal to 8. We find log 3 to the power x is equal to log 8. And that x drops, so s log 3 is equal to log 8. Now, to get the value of x, I divide through by log 3. So I have this. And this same question can be approached by converting the original question into logarithm. So from indices, we are converting straight to logarithm, and that we have log of 8 to the base 3 is equal to x. So these two methods are the same, or they are very similar. Okay, so they will give us the same answer. So we go ahead, find the value of x to be equal to 1.893. So that's for our first example. The second example, we have 2 to the power 2x minus 1, and this expression is equal to 12. Okay, so straight away, I'll convert to indices and say log 12 to the base 2 is equal to 2x minus 1. So that is the method I'm using. And if I get this one, then I'll say log 12 to the base 2. Then I'll try to find its value. Log. So that will give me 3.585. And this one is equal to 2x minus 1. So this is what we have. And when I group, I'll get 2x is equal to 4.585. Okay, so to get s, I divide through by 2. So 4.585 over 2. So x here is now equal to 2.2925. That's it. Solve the following equations. Equation 1, log to the base root 3 of 9, and this expression is equal to x. So we start solving. So our solution here. Okay, so we have log to the base root 3 of 9 is equal to x. And this can be converted to indices as 9 is equal to root 3 to the power x. Can rewrite this as 3 to the power 2 is equal to 3 to the power half, and then multiply by power x. So I continue. So 3 to the power 2 is equal to 3 to the power x over 2. Now, since the bases are the same, I can equate their exponents as 2 is equal to x over 2. So I'll do multiplication, I'll multiply through by 2, and I have 4 is equal to x. So my s is equal to 4. Now the second example, I have log to the base 2 of 2x plus log to the base 2 of 8x, and this expression is equal to 4. So I will rewrite this expression as log of 2x times 8x to the base 2 is equal to 4. And then I will have that as log of 16s squared to the base 2 is equal to 4. Now from here, I have two options to go through this. It doesn't mean it's limited to two options. If you get another option, you can still work with it. So I am going to use two approaches from here on. So the first approach, I'm going to use two different colors for the two approaches. The first approach, I'm going to convert what I have now to indices, and that will give me 16s squared is equal to 2 to the power 4, which becomes 16s squared is equal to 16. Now if I divide through by 16, I'll get s squared is equal to 1. Then I have to find square root of both sides. So square root of s squared is equal to plus or minus square root of 1, and that will give me x is equal to plus or minus 1. However, negative of log is not possible. So the answer here is x is equal to 1. So the negative will be taken out. So we are going to choose 1 as our final answer. Then the second approach. So from here, from where I got 2, and that's this side. From here, what I will do is to rewrite the expression as log 16 plus log s squared all to the base 2 is equal to 4. So I have separated the two, the product of the two, and this one becomes log 2 to the power 4 to the base 2 plus 2 log x to the base 2 and is equal to 4. So this becomes 4 log 2 to the base 2 plus 2 log x to the base 2 is equal to 4. I can divide through by 2, and that will give me 2 log 2 to the base 2 plus log x to the base 2 is equal to 2. So the first expression becomes 2 times 1, which is 2, plus log x to the base 2 is equal to 2. I will group like terms and obtain log x to the base 2 is equal to 2 minus 2, which is 0. And if I convert this to indices, I will get x is equal to 2 to the power 0. And if you remember, 2 to the power 0 is any number to the power 0 is equal to 1. So x is equal to 1. So this is our second approach. Okay. Solve the equation log to the base 5 of an expression in brackets, and the expression is x plus 2, and this expression is added to log to the base 5 of another expression in bracket, which is s minus 2, and all this is equal to 1. Okay, so we solve. We have log to the base 5 of x plus 2 added to log to the base 5 of x minus 2 equals to 1. So if I look at this, I can write as log to the base 5 of x plus 2 multiplying x minus 2, and this is equal to 1. So I will change this to indices, and that will give me x plus 2, x minus 2 is equal to 5 to the power 1, which is equal to 5. Now when you look at the product of the two expressions in bracket, they give us difference of 2 squares. So s squared minus 2 squared is equal to 5. And that I will have s squared is equal to 5 plus 2 to the power 2, which is 4. So s squared is equal to 9. So I find square root of both sides, and I have root of s squared is equal to root of 9. I'm limiting myself to the positive because a negative will, will not be appropriate. So I will stick to the positive. When we substitute the negative value for x into the expression, it will not be appropriate. So we have x is equal to 3 as the answer. Okay. So this example is very similar to the one we just did. We are to find the truth set. So this one specifies as truth set. Okay, so we go ahead and solve to determine or to find the truth set. We have log to the base 4 of 11 plus 9x. Then we are subtracting this from, we are subtracting log to the base 4 of 11 minus x from it, and the result will be 2. Okay, so this one, because of the subtraction, we can rewrite as log to the base 4 of 11 plus 9x divided by 11 minus x, and this is equal to 2. So I can change this to indices and obtain 11 plus 9x divided by 11 minus x is equal to 4 to the power 2. So if I multiply through by the LCM, I will get 11 plus 9x is equal to 4 is 16 multiplying 11 minus x. So here 11 plus 9x is equal to 176 minus 16x. So I group like terms. have 9x plus 16x. This is equal to 176 minus 11. So 16 plus 9 will give me 25x, and this is equal to 165. So if I divide through by 25, my x is going to be 165 over 25. So x is equal to 6.6, and that the truth set becomes s is such that s is equal to 6.6, and that's the final answer. Now we come to logarithmic simultaneous equations. So simultaneous equations that are in logarithms. Example, solve the following simultaneous equations. So we have log x plus log y equal to 1 and x plus y equal to 11. So as you can see, our first equation is in a log form. So let's solve and see how we go about it. The first one, we have log x plus log y is equal to 1. What I will do is to apply the law of addition in logarithm, which gives me log xy is equal to 1. And now I also want to convert it to indices. So as you can see, the base of the log has not been written, which implies that it is in log 10, or it is in base 10. So that will be xy is equal to 10 to the power 1, which is the same as xy is equal to 10. And that will be taken as our equation 1. Then we will take x plus y as our equation 2. So we have these two equations to solve simultaneously. What I will do is, from equation 2, I want to make s the subject, and that will give me s is equal to 11 minus y. Then I will substitute the result into equation. I'll substitute the result into equation 1, and that becomes 11 minus y multiplying y is equal to 10. So that gives me 11y minus y squared is equal to 10. So if I simplify again, or I rearrange, I'll have y squared minus 11y plus 10 is equal to 0. Now I'm going to solve the quadratic equation obtained. So I have y squared minus y minus 10y plus 10 is equal to 0. That is, I believe you already know how to use a method of factorization to find the root of a quadratic equation. That's what we have applied here. Okay, so y out, y minus 1. And then negative 10 out, y minus 1. This is equal to 0. So y minus 10 multiplying y minus 1 is equal to 0. That means y minus 10 is equal to 0, and that y is equal to 10. And then y minus 1 is also equal to 0. That means y is equal to 1. Okay, so we also go ahead and compute for their associated values. So when y is equal to 10, then x will be equal to 11 minus 10. This, I am referring to this expression or this equation obtained, and that my x will be 1. And when y is equal to 1, that means that x will be equal to 11 minus 1, which will give me x is equal to 10. So the values of x and y are x is equal to 1 or 10, and y is equal to 10 or 1. So these are the values of x and y as required. Okay, so we have our second example. We have 2 log x to the base 3 minus 3 log y to the base 3 is equal to 7. That should be our equation 1. And we have log x to the base 3 minus 2 log y to the base 3 also equal to 4. Now, when we look at the two equations, you realize that we have two similar expressions. So this one here is log s to the base 3. And when we look at the second equation, we also see the same expression there, log s to the base 3. Then when we come to the next one, we have log y to the base 3, and then we also have the same expression, log y to the base 3. Okay, so with these similarities, we are going to do some representation. So we let log x to the base 3 be equal to, let's say, m, and log y to the base 3 be equal to n. So when that is done, our two equations will become 2m minus 3n is equal to 7. That's our equation 1. And then the second one, we have m minus 2n is equal to 4, being our equation 2. So from here, we see how we solve the two equations simultaneously. So I will multiply equation 2 by 2. Okay, so precisely by negative 2. So that gives me negative 2m plus 4n is equal to negative 8. So I'll label this as my equation 3. Then I'll continue by adding equation 1 to equation 3. So equation 1 plus equation 3. Okay, so that gives me 2 plus negative 2 will become 0. Negative 3n plus 4n will give me n, which is equal to 7 minus 8, which is -1. So my n is -1. And then I will substitute n into equation 2. And that will give me m minus 2n, which is -1, is equal to 4. So m plus 2 is equal to 4. M is equal to 4 minus 2. So m is equal to 2. So that is it. Now I have m and n. However, m and n were not in the original question, so we put them back where we took them from. That is, m is representing log s to the base 3. So log s to the base 3 is equal to 2. So that means x is equal to 3 to the power 2, which is s is equal to 9. Then we also come to log y to the base 3, and that we are also told that is -1. So if I convert that to indices, I have y is equal to 3 to the power -1. That means y is equal to 1/3. And that is the solution to the simultaneous equation given. So we have another example. 3 log to the base 2 of m is equal to n. So, and then log to the base 2 of 4m is equal to n plus 4. We have to find m and n. So our solution, you have 3 log to the base 2 of m is equal to n. And then, so that counts as equation 1. And then I have log to the base 2 of 4m is equal to n plus 4. That also counts as equation 2. Now I'm going to substitute equation 1. So n 3 log to the base 2 of m for n in equation 2, and that will give me log to the base 2 of 4m is equal to 3 log m to the base 2 and then plus 4, like this. If I continue, I'm going to have log 4m base 2 minus 3 log m base 2 is equal to 4. And here I will rewrite as log 4m base 2 minus log m to the power 3 base 2 is equal to 4. This I can simplify as log 4m over, oh, this one I didn't write well, it should be m to the power 3. over m to the power 3 base 2 is equal to 4. So this one becomes, if I convert to indices, it becomes 4m over m to the power 3 is equal to 2 to the power 4. Okay, so this one, I can do some cancellations, which will give me 4 on m squared is equal to 2 to the power 4. Okay, so that's what I have. And so 4 over m squared is equal to 16. I multiply through by m squared, and that will give me 4 is equal to 16m squared. I divide through by 16, and that will give me m squared is equal to 4 over 16. That is, m squared is going to be 1 over, so 4 goes into itself, 1 goes into 16 4 times. So this is what I have. And if I find the square root of both sides, I have root m squared is equal to plus or minus root 1 over 4. So this is supposed to give me m squared is equal to plus or minus 1 over 2. Sorry, m, rather, not m squared. But because we cannot substitute the negative m, we conclude that our m is equal to 1 over 2, positive. We have another example here. So we have this equation, and then we have this equation to solve simultaneously. So let's go ahead and solve. For the first equation, we have log to the base 10 of an expression in bracket x minus 2, and then plus log to the base 10 of 2. This is equal to 2 log to the base 10 of y. So I will rewrite this expression to simplify it as log of 2 times x minus 2 in bracket, and this is to the base 10, equal to log y squared also to the base 10. And this, I have to find antilog of both sides. When I do, I'll get 2 multiplying x minus 2 is equal to y squared. And I will just open this bracket and have 2x minus 4 is equal to y squared. And I'll label this as my equation 1. And then I'll take the second equation, which is log to the base 10 of an expression in bracket, which is x minus 3y plus 3 is equal to 0. And this one, I'll convert to indices and obtain x minus 3y plus 3 is equal to 10 to the power 0. Okay, and this one is x minus 3y plus 3 is equal to 1. Let's remember, any number to the power 0 is 1. So this one counts as my equation 2. Then from equation 2, I will make s the subject and obtain s is equal to 3y plus 1 minus 3, which will be s is equal to 3y minus 2. Okay, now I'm going to substitute this into equation 1, and that will give me 2 multiplying 3y minus 2, and then minus 4 is equal to y squared. So I get 6y here, minus 4 is equal to y squared. So 6y, I'll group them and obtain y squared minus 6y. So 4 and 4 will become minus 8, and because I'm grouping them, it becomes plus 8 is equal to 0. So I have a quadratic equation and I have to solve. So I'm going to use the method of factorization. I have to find two numbers. When I multiply, I get 8. When I add, I get negative 6. So I'll have them as minus 2y minus 4y plus 8 is equal to 0. So I factor out the y. So y bracket y minus 2. And then here I'll factor out negative 4. And I have y minus 2 is equal to 0. So I have y minus 4 on one hand, and then multiplying y minus 2, which is equal to 0. And then here I'll have y minus 4 is equal to 0, which is y is equal to 4. Or y minus 2 is equal to 0, which is y is equal to 2. So I have two values for y. Now when y is 4, what will the value of x be? So we are substituting into the expression y is equal to 3y minus 2, and that our x will be 3 times 4 minus 2, which is 12 minus 2, and that's 10. Then when y is 2, x will be 3 multiplying 2 minus 2, which is going to be 6 minus 2, and that's 4. And that will be the solution to the question.